U-substitution is a process to evaluate an integral. When taking the integral f of g of x dx, you first determine your u, which is equivalent to gx, and your du, which is equivalent to g prime of x dx. To obtain your integral, f of u du. Now, with g prime of x, it needs to be in the original integral, so you're going to add that. Oftentimes, if it's a certain number, you're going to have to take a fraction of it. Okay? Now you're going to integrate with respect to u. And replace u with g of x in the result. The old method would take the integral of each term whereas the new method, using U-substitution, determine your u, which is 2x plus 1. Determine your du, which would be 2 dx. Now you need to have a 2 in the problem, so you're going to bring that in. And divide by 1/2. You have the integral then of 1/2 u squared du. Take that. You get 1/2 u cubed over 3 plus c. When you solve that out, you get Now you notice that the u is replaced with the u from before, the 2x plus 1. We'll now do 2 problem examples. The integral of 3x over x squared minus 5 dx. First, determine your u, x squared minus 5. Determine your du, which is 2x. Place that in your problem. multiplying the problem by 2 over 3, and multiplying the outside by 3 over 2. You're going to take the integral of 3/2 du over u. In a division problem, the ending is ln times the absolute value of a plus c. Absolute value of u plus c. So your answer will end up being 3/2 ln absolute value of x squared minus 5 plus c.
Okay, next we will integrate with trig problems. Take the integral of cosine of x dx over square root of sine x. First you set up which one is u, or what u is, which is sine x. Next, you take the integral of that, which is negative cosine x. When you put that into the problem, it's the integral of du over the square root of u. Then integrate this to make it u to the 1/2 over 1/2 plus c. This equals 2 times the square root of u plus c. Then you got to plug whatever u is back in, which equals 2 times the square root of sine x plus c. And that's how you do trig problems with U-substitution.